Hello students, welcome back. How are you? So today we'll do a new exercise that is 1.2. In the last class we have done 1.1, all the questions you have seen. So today in exercise 1.2, what we learn? We'll learn about real number. Okay. So in this exercise we have three questions. Question 1, 2 and 3. And we'll do 1 and 2 and 3 I'll do bit later. Okay, so let's start. First, to start with, let's understand what is a real number. Okay, so real number, you have to understand what is a real number. What do you think? What is a real number? We have seen so many types of numbers, isn't it? Natural, whole number, integers, rational numbers, irrational numbers. So now we'll see what is a real number. Okay, so real number, see what is a real number. See the diagram. This is my real number. See what is a real number. If I take the big circle as a real number, and inside two circles you can see one is rational number, one is irrational number. See, rational number, 3 by 4, 5 by 6. Okay, and here root 2 and root 3 are irrational number. Any number having root which you cannot take out, like for example root 2, root 3, you can take even root 5 also. Okay, but not root 4, because root 4 you can take out 4. So irrational number root 2, root 3, root 5, root 7, like that number. A rational number, as we know earlier, that 3 by 4, 5 by 6, or any number like 3, 4, 5, 6, all those numbers are also rational number. So once you have rational number and also irrational number, all this rational number and irrational number, you can call them as real number. That means all the rational number are real number, all the irrational number are real number. So real number is either rational, it can be rational only, or it can be irrational, and sometimes it can be both. Okay, so some examples of real number I can take. Examples. Okay, let's take some examples. See, example of real number. See, 3, 3 by 4, 5 by 6. I can take root 3, root 2, root 5. These are irrational, these are rational. Both this type of rational and irrational number are called as real number. So with the concept of real number, let's proceed to question number 1. Okay, let's do question number 1. So what is the question in question number 1? State whether the following statements are true or false. Justify your answer. So some questions will be given where you have to say true or false, and if it is true, you have to justify that answer. For example, let's see the question number 1, option number 1. Every rational number, can you see this? Every rational number is a real number. What do you think? This every rational number is a real number. Is it true or false? Hmm? Every irrational number. Let's take some example. Every irrational number. This is irrational number. As we know, irrational number are root numbers. Root 2, root 3, root 5. Okay. Every irrational. This is the set of irrational number. For example, I have taken 3 numbers only. You can take as many as you want, and any irrational number you want, you like. So this set is a real number. Is it true? Because in real number, what I have in real number, I have both rational and irrational. So this root 2, root 3, root 5 also I can have here. Root 2, root 3 and root 5, because real number is irrational also. So that means every irrational number, set of every irrational number is present in the set of real number. That means your answer is true. Okay. Any problem? So yes, write the answer now. True. This will be true. Why? Because collection of this real number is made up of is made up of rational and irrational number. See, real number is made up of rational and irrational. Rational and irrational. Okay, what is this? Okay, irrational. Is it okay? So every irrational number is a real number. You see this diagram. Root 2, root 3, root 5 are the irrational number. This irrational number are present in this set also, which is a real number. So it is true. To make it more clear, let's see question number 2. Okay, what is question number 2? Every point on the number line. Every point on the number line. What is the meaning of this? If I take a number line. Okay, this is 0. This is 1. This is 2. This is 3. This is 4. In this side, -1, -2, -3. So it goes on. Okay, this is -3, -2, -1. Okay, so every point, for example, let's take one point, this point. Let's take this point. 4 is of the form m. Is it 4? Can I write this point in the form of this? Okay, this 4 I can write as 16. Yes, that means 4. So this 4 I can write as root 16. Similarly, this 3 also I can write root 9. 2 I can write root 4. 1 I can write root 1. So 0 is 0. So this side, all these points on this number, all these points I can write in the form of this root 16. Yes, I'm getting 4. Root 9 I'm getting 3. Root 4 I'm getting 2. Root 1 I'm getting 1. So yeah, true. This positive side, it is true. But what about the negative side? Can I write -3 in any root form? Like for example, if I take -9, is it true? Root -9 is equal to -3. Is it true? No. This is an imaginary number. This will become like this: 3 root -1. Okay, in later classes you will learn this also. 3, this root over -1 is I. So 3i means 3 imaginary. So this side I cannot write. Is that clear? See, let me show this also. Minus root -2. So let me put like this. Can I write like this? This -2, can I write root in the form of root -4? No, because this will be 4. If I take out, it will be 2 and then minus, and then nothing means you can write 1. Okay, so this is 2. This root -1 is I, imaginary number. In the upper classes you will learn all these things. That means this side I cannot write, but this side yes I can write. So overall your answer will be false, because this side I can write but this side I cannot write. So write the answer, it is false. It is false. Why false? Because these negative numbers, the negative numbers cannot be, okay, let me rub this. Are you understanding what I'm saying? Because all these negative numbers, this side, negative side, cannot be written in the, sorry, what's happening, form of root n. So this is your answer. It is false because the negative numbers on this side, okay, you cannot write in the form of root m. Is it clear? So let's go to question number 3. What is question number 3? Every real number. So this is a set of my real number. Okay, I can, let's take some example. Rational number I can take 3 by 2, 4 by 5, any number. Irrational number I can take root 2, root 3. Okay, so this is the set of real number. Every real number is an irrational number. Is it true? No. Some real number like this irrational number I can have here. Okay, root 2, root 3. Some real number, for example, only the irrational number can be irrational number, but this rational number are not there. Means that the whole set is not present in this set. There are two part in these questions. First you write real number set, and the second part is irrational number set, and just check whether the numbers in this set are present in this set or not. Obviously not. Only some part is present. Root 2, root 3, root 2, root 3. So overall answer will be again false. False. Why? Because let's take rational number. Because 3 by 2, what is it? It is a rational number. Which is a 3 by 2 rational number, which is a real number. Real number, but not irrational. Is it clear? So I hope you understand all these three parts. Now let's go to example 2. What is the example 2? Are the square roots, are the square roots, are the square roots. Let's take this square root, one square root at least, of all positive integers, of all positive integers. Let's take any positive integers for irrational. I'm getting this 2. Are the square root of all positive integers. Okay, before that, what are the positive integers? Let me give you overview. Okay, I know if I start from 0, this is my 1, this is my 2, this is my 3, this is my 4. Okay, it goes like this. These are positive, don't take negative, only the positive, because in the question it has asked for the positive numbers. Okay, so are the square root of all positive. So let's take this, let's take root 1 also, 1, root 2 also, this 2, this 2, this is root 2 only, and root 3, I'm getting root 3, and root 4 I have written already, but still let me write it here. Root 4 is 2. Okay, let's take only 4 positive numbers. You can take more, and if you find the root, what I'm getting here 1, I'm getting here root 2, I'm getting here root 3, I'm getting here 2. So here this 2 is a rational number. Yes, root 2, root 3 are irrational number, but this 2 is a rational number, 1 is a rational number. That means what? Are the square roots of all positive integers irrational? No, the square root of all positive integers are not irrational. Yes, some might be. See, some might be square root of some positive numbers might be irrational number, but not all. For example, root 4. See, 4 is a positive number. I have taken the root. Okay, so after taking this, I'm getting 2, which is a rational number. So your answer will be no. Okay, your answer will be no. Why? Because, for example, if I take the square of 4, I'm getting 2. I'm writing the last one. Is a rational number. It is not an irrational number, it is a rational number, so your answer is false. Hope you understand. Okay, so if you understand, let's go to question number 3. And question number 3 I'll show you in the next class. Not in the next class, obviously I'll take in some other classes all the root, how to find the how to show this root 5 on the number line, root 3 on the number line. This type of questions I'll show you in my later classes, not now. So I hope you understand this exercise 1.2, and in the next video I'll do all the examples of exercise 1.3. By then, see you and thank you for watching.